So in the previous lecture, what we just did was we just made this ARP request. We made this broadcast map just to get this from this Ether framework, that is just denoting this is a virtual MAC address that will just get every packet to launch, or basically it will deliver every packet to the clients on that network. And we just combine those broadcast and request packet with this escape one function, which is this forward slash, which is going to just combine this packet, and we are just going to show over here, that is this layer. So if I just run this main, you will see each of these layer printed out here. So let me just wait a moment, and it is going to give us this Ethernet, everything about here. So it is ARP, and it is combination of Ethernet and ARP, which is this broadcast, which is combination of this broadcast and the request packet. So next thing, if you just remember what I have told before was in this demo, if I just make a quick revision, that we just made use of this ARPing to see that MAC address and the IP of the clients that is connected to the network. So let me just run this one more time, that is this demo, and you will see now that it will just get every of these clients that is connected to this network quite easily, which is basically using this ARPing method. So you can see here it has received the 3 packet, got 3 answer. That means we have this answered package and unanswered packets. So these are the 2 responses that we get while using this escape module. So that means you can also see here we have to now send this packet. So basically we have already created now the packet. Now we have to send this packet to the broadcast MAC address so that it will just get every ARP response from the client. So as to do that, we have to first use some method of the escape. So that means we'll just say response 1. So I'll say response 1 and response 2. So this response 1 is the answered, and the response 2 is unanswered part. So we have this method, important method of this escape module, that is SRP module or SRP method. So this SRP method is a class that is going to just get every information transferred or packet that is transferred to the client. So this is important method. So I have to now pass here this request broadcast, which is our packet that need to be sent. And next thing what we can do over here is the timeout. So we can just add this timeout attribute over here to just indicate that there should be timeout, maybe after maybe 1 second or maybe after 2 seconds. So it can be about 1 second. So for now I'll just put here 1 second. So what we just did over here was we just made use of this SRP method to send our request broadcast that we just made over here at the timeout of 1. So now let me just close this down. So we just get now answered and unanswered. So this first one is answered packet and second response is unanswered packet. So let's see now what we can do with this answered packet. So before that, you can see this was our ARP protocol. So let me just give the message right over here. So let me say this is our request, which is ARP request. And now if I just say something like summary, if I want the summary to be printed, so let me just print this first, and let me show you what this summary looks like. So if I just run this, and it is main. So if I just run this, then you will see that it will just take more time now, and now it will say that ARP who has none says that this is your source. So this is your source IP, which is going to just send that ARP request to the destination MAC, or basically to the broadcast MAC address, which is your this MAC address, which is virtual MAC address. And if I have to check this machine, that is the IP address, then you could see this is our source and its MAC address is right printed over here. So next thing is who has none. So this none is basically your these IP addresses that you just pass here. We haven't stored anything to here. So if you just remember from the previous couple of lectures before, this DST was the destination MAC address. So we just saw how we can just get these references. So that was the process to list every argument that was with this ls method, and now we have to make use of this ARP class to just list all of these arguments that we have here. So let me just comment this out, because we don't want this summary, we want this escape ARP here. Let me run this main. You will see the list of an argument that is available for the ARP now. So you could see these are the list that is available. So if you see here, if you just get the printed this summary too, let me just run this one more time. You will see summary will be told over here, that is saying ARP, that is obviously this ARP request who has none. So if you see here, this field is none, which is PDST field. So this is none, and this SRC field is for the MAC address, PSRC is for this IP address of the client. So for now we have to make use of this PDST, because this is none, that means we can now include as an IP to this field. So same as we have done in the case of broadcast, we just saw how this was the field for the destination MAC address, and we just assigned this virtual MAC address to this destination MAC address. Now it's time to do that for this ARP request. So to do that, we have the request, which is obviously this request, and if you see here, that argument or that field was PDST field. So this was the field which has this none. So I have to now include that this is PDST, and that should be IP. So you can do this way, or there is also the another way to do this, and let me show you. So the another way to do is inside this parenthesis. So simply type PDST, which is the field, and now just pass the IP that you just passed over here while calling this scanner method. So we have now completed this ARP request. Let me just comment this out, which is to print the summary, and let me just remove this, or basically let me also comment this out. So now we have created our own escape request, that is ARP request over here. We have now created this broadcast MAC address, which is for this virtual MAC address. Next was we just combine those packets. We send that packet with this SRP function with the timeout assigned as 1 seconds, and we get this response. So this first one response is answered response, and the next one is unanswered response. So now let's see how we can just navigate to this answered and unanswered request. So first of all, before doing that, let me tell you this response, which is answered and unanswered, that we saw in the case of the demo. If I show you the output when we just run this demo. So okay, we haven't run this, so let me just run this real quick, and this was the demo, and this was going to give us, that is the answered package and unanswered. So this remaining 253 packets were unanswered. That means we have to now see what these responses are. So basically these responses are stored in the form of list. So you can check the documentation of escape to see that in the documentation it has written that these responses, that is answered and unanswered, are in the form of list. So if you just remember what we learned in the list section, that lists are iterable, that means we can loop over the list. So let me loop now. So for element in this response 1, so we are going for the response 1, which is for the answered packets. So for every answered packet, let me just print this first, which is this element, and let's see how this works. So first of all, so the thing we want to run is main, obviously, and let's see if this works or not. So okay, the next time it works. So there was no any problem. Got 3 answers. It is saying that 3 is connected. So there is 3 machines or client that is connected to this network. So you could see the clear code over here, that is we are getting the response from this SRP, and that is on the timeout 1. We are just sending this packet of request broadcast. Just remember that PDST was to show the IP address. This is important, and basically we made this ARP request packed with this broadcast map, and that is sent over the client, which is in fact in the form of the responses. So this is response 1, this is response 2, and based on that response we just loop, because these responses are answered and unanswered. So if you just go in the demo, you could clearly see it has shown that with the AR ping there is the two packets, that is answered and unanswered. So first one is answered, so we just loop on this answered, we just print this one, and we get the result. So you could see result right over here. It is giving us the result in the form of this list containing two part. So let me show you here. This contains two part. So this is one part, and the next part here is this part. So you can clearly see the next part is this long part. So if you check the documentation of Escapee, they have written that the first part, which we have seen right here, so you can see there is a two part that is containing one part over here. So you can just distinguish this with the comma, so there is comma in between them. So first part here is the input part, or basically this is the request part, and the next part over here is the response part. So this has the three clients that is connected to the network. So first one is obviously the gateway, second one is this client, and the third one having this IP address, and you can go over here to see the MAC address. So you can see this is the source that is having the MAC address. You can get this MAC address with this HWDST, that is for the MAC address. We have already seen this while we just make use of this escaping. So let me show you right over here. When we just see this ARP, so let me just list out again. So with the escapee, and it should be ls, and let's go for this ARP. Let me just list out the things that is going to show us the argument that is denoting us about the MAC address and the IP address. So you could clearly see over here, this SWDST was, okay, this SWSRC was for the MAC address, and PCRC was for this IP address, which can be also seen right here. So this is your MAC address. We have another, this is the IP address. So we just get some of this client that has just connected to us, or basically they have sent us the packet in the form of ARP response. We just get this response. So you can also see the unanswered part with this response 2. If you see, this is the response 2 which is unanswered. So let me just run this unanswered part over here. It will just take some time because it is much more than that of answered one. So there was a small answered one, they were quite of 3, but this you can clearly see there is 253 packets that is unanswered. Only 3 were answered, that means 3 clients were connected. 253 packets was dismissed, or basically this was not doing anything. This means this packet was not giving any ARP response, but these 3 clients gave ARP response. That means there are 3 clients, we got their MAC addresses, we got their IP addresses. So now let's see only the IP addresses and the MAC addresses from this response 1, because this is all the unnecessary information that we get from here. So let me just comment this out first, and if I just run this main again, you will see we have these responses in the form of this list. You can see this is the list, and this, or basically you can also see the tuple. So this is a tuple, and this tuple contains the request part and the response part. So we don't need this request part because this is unnecessary information. We just want this ARP response part because this has the critical information about the MAC addresses and IP addresses. So let's get this part of the list or a tuple. So you know the list or a tuple indexes start from 0th index. So here in, let me just, okay, where is this run? So this part, or basically before comma, is at 0th index, and after comma is at 1 index or first index. That means we can now get the first part of this element. So let's do that first. So we can do something like, okay, here I'll just say that in the element I want only the first part, not the 0th part, because 0th was the request. We don't want the request, and we have now only the response part. You can also do something like here, because these responses, I have already told you, these responses are also in the form of the tuple. That means we can also get only the request part from this 0th, because the 0th is the insert part. If you want the uninsert part, that will be at 1, but we want the insert part, that will be at 0, and we get the response, which is the insert response. We just loop on that and we get the insert, that is insert responses. If I just run this now, we'll just get the information that is much more available, or basically much more valuable than before. So you can see we have now information that is in the form of gibberish. So we have to now filter this. So in order to filter, what you can do is use the argument. So we have learned how to take the use of p, that is src, and the next one would be to print the MAC address. So it will be element 1, which is showing us that this is the response, and src is for the MAC address. So this psrc is for the IP address, and this is for MAC address. We'll just get this information. Let me just print this one more time. You will see now it will just run its code, and it will get us the IP address, it will get us the MAC addresses, IP address, MAC address. So let me format it here. After every print, or basically after every client, I want to print some spaces. So this much spaces will be enough. Let me just run this again. You will see now it will format, it will just give us the information that is much more efficient. So let us go over here. You can see there is 3 client. This is the gateway, this is the MAC address, this is the gateway, this is the MAC address, this is the gateway, and this is the MAC address that we just catch from these responses. So in this lecture, we just made a complete scanner using this escape. So first of all, we just made the ARP request. We bind it with the broadcast over here by using the escape /. We just send that to the broadcast MAC address, which is done by this SRP, which will send this packet to all of the client. We just get the response from the client, which is insert part. If you want to see the uninsert part, it will be at first index, and now we just loop around it. But in this case, the information that is valuable will be at the 0th, because we want the insert part, because the insert part will be connected clients. So we'll just get the insert part response, we'll just loop on that, we just get these IP addresses and MAC addresses, we just format it, and we'll just print this in the way that normal scanner will do. So this is the same scanner that will be something like we do in the case of a NetDiscover, which is the Kali Linux tools. We can also do the Nmap scanner, which is the case which we just get the MAC addresses and IP addresses of the clients that is connected in the network using this program. So we just made a complete program which can work as a scanner. So this will be wrap for this lecture. See you in the next one.